Unit 4, Day 3. Proven triangles are congruent by two postulates. One, side, 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 and the other, side, angle, side. Initially, we showed that to prove triangles are congruent, all the sides and all the angles had to be congruent. Now, we're going to learn two postulates where we use fewer parts. If we can show that three sides of one triangle are congruent to three sides of another triangle, then we can say that the triangles are congruent. So looking at the picture and the markings, I can tell which sides are congruent. One tick mark, so those are congruent. Two tick marks, so those are congruent. Three tick marks, so they are congruent. Therefore, we can say triangle ABC is congruent to triangle DEF. So we took three sides of one triangle that were congruent to three sides of the other, and now we're able to say that the triangles are congruent. So that means angle A is congruent to D, angle B is congruent to E, and angle C is congruent to F. And we didn't have to prove all six things were congruent to each other, just three. So in this section, what we're going to do is we're going to use proofs to prove that triangles are congruent. And the very first thing you want to do is you want to make sure that you mark up your picture first. And you're going to mark it with the given information. So I start off by writing or marking PQ is congruent to ST and the QR is congruent to RT. So this next bit of information, R, is the midpoint of PS. Anytime we see the word midpoint, we know something is going to be equal. So R right here is right in the middle of PS. So what that means is that it splits it into congruent parts. So P to R is congruent to R to S. So when I take a look at it now, I can see three sides of one triangle are congruent to three sides of another. Therefore, the triangles are going to be congruent. So let's go ahead and write in the reasons. So take a look at this. My first reason, second reason, and third reason were all given because I could find them up here where it says given. However, PR to RS was not given. However, we can determine that because of the definition of midpoint. So now that I've proven that three sides of one triangle are congruent to three sides of another, I can say that the triangles are congruent because of side, side, side. So this is what we do when we write our proofs. So we definitely want to mark the picture first. So once I mark the picture, I can clearly see that JL is congruent to MN, K is the midpoint of JN and LM. So I was able to mark those two blue and these two black. Why? Because anytime we see the word midpoint, we know that something is equal. So let's get ready to fill in the proof. So here we have the first two reasons are given, and then we get here to JK is congruent to KN. And when I look up here at my given, I don't see that. However, we can conclude that because of the definition of midpoint. So now when I look back at my picture, I see three sides of one triangle are congruent to three sides of another. Therefore, the triangles are congruent by the postulate called SSS, which stands for side, side, side. So I introduced to you our second postulate for proving triangles are congruent, and it is called side, angle, side. Now I want you to pay close attention that the included means the angle is between the sides. So here when you look at it, you see the angle between the sides. So here we go. So here I wrote down corresponding parts, and AB is congruent to DE. Just check out your picture. Angle B is congruent to angle E. Just check out your picture. And side BC is congruent to side EF. So if we have that information, can we show the triangles are congruent? Yes, we can. Triangle ABC is congruent to triangle DEF. Before we move from this slide, I just need you to know that the angle must be between the sides. Okay, so here we go. We're going to prove this triangle is congruent. These triangles are congruent. What's the first thing we want to do? Absolutely, we want to mark our parts. So JM is congruent to NL. And then we have angle JMN. Just trace it out, and we definitely want to concentrate on the angle in the middle. So we're going to start at J here. We're going to go to M and back up to N. So that means we're talking about this little angle in here. We're going from L to N to M, from L to N to M. So that means we're talking about this little angle in here. So I have a side, I have an angle. What else do I see? Always look for shared sides. These triangles are connected because they have a shared side. If I were to pull these apart, I could clearly see that this is a side, this is an angle, and this is a side. This is a side, this is an angle, and they have a shared side. So I'm looking at proving these are congruent because of side, angle, side. Let's fill in the proof. So we have the first statement, y is given. The second statement, y is given. But take a look at this one. Mn is congruent to Mn. What is it when something is congruent to itself? You got it. It's the reflexive property. So anytime you see a shared side, you're going to write it is the reflexive property. So a shared side. Why are these triangles congruent? Because of the side, angle, side postulate. Mark this one, try it on your own, and then come back and check the answers. There you have it. I marked everything. I showed the shared side. So when I got ready to put in my proof and I saw the shared side, that's the reflexive property because anything is congruent to itself. BD is congruent to BD. When I look back at my picture, I see side, angle, side in the top triangle. That's congruent to a side, angle, side in the bottom triangle. Therefore, the triangles are congruent. Okay, I want you to try this one, but we're going to go over the directions together. And the directions state whether the triangles can be proven congruent. If so, side, 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 or side, angle, side. And then what? Write a congruent statement. You try it. So I've marked everything. I called this here S1. One tick mark. I came over here and found this one tick mark and I called it S1. So I have a side congruent to another side. I called this one with two tick marks S2 and I called this one S2. So those two are congruent. I see one arc here and I see one arc here. So those two angles are congruent. Then I have a side, and I have an angle in between. I have a side, and I have an angle in between. So the question is, are these triangles congruent? The answer is yes. What's the postulate? The postulate is side, angle, side. Now I need to write a congruency statement. Triangle something is congruent to triangle something. Push pause, and then you try to figure out what it is. So my statement is QYT is congruent to triangle CKP. Why? Well, if I go from Q to Y, I pass side 1. If I go from C to K, I pass side 1. If I go from Y to T, I pass side 2. And if I go from K to P, I pass side 2. So you want corresponding parts to match up. Okay, this one is tough, but we're going to read the directions. State whether the triangles could be proven congruent. If possible, use side, 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 or side, angle, side, and then write a congruency statement. You try it, and then come back. Okay, so I noticed that I have side 1 congruent to side 1. How do I know that? Because of the markings. What I notice here is that angle M and angle K are congruent because I see that marking. If you don't see it, here below I've split up the triangles. I've slid them apart. So now you can see angle M with the one arc and angle K with the one arc are congruent. Again, you should notice that this says M to K and this says M to K. What does that mean? They are sharing a side when I pull them apart. So when I look at it, I have side, angle, side in one triangle, and I have side, angle, side in another triangle. Therefore, these triangles are congruent. And the last thing we need to do is write a congruency statement. You try. All right, so take a look. It may be easier to see after I pull these apart. So I go from J to M to K. Up here, J to M to K is congruent to L to K to M. So these triangles are congruent, and so are their corresponding parts. Okay, so for number 1, are these triangles congruent? And the answer would definitely be no. The first thing I notice is that I don't have 3 sides, so it definitely could not be side, side, side. Okay, so that's not it. And if I want to check side, angle, side, I need to make sure that the angle is between the 2 sides. Take a look at this angle and take a look at this angle. It's not between the 2 sides. Now, had it been angle, angle P, that would be between the 2 sides, or angle U would be between the 2 sides. However, it's not those. So what can we say? We can say these triangles are not congruent. So page 18, given the coordinates, determine whether the triangles are congruent. Okay, so we have coordinates. You could graph it if you like. However, you're still going to have to use the distance formula. So you try. So we use the distance formula for the first 2 sides, and we see that one side, PQ, is square root of 185, and one side, XY, is also the square root of 185. Let's check out the next 2. Well, when I use the distance formula on these 2, I got a different answer. This is a square root of 34, and you can definitely find the decimal if you like. And this is a square root of 61, but I got to keep going. Okay, so it seems like I'm back on track, so I am going to list my congruent sides. So here we have it. I listed all the congruent sides and what they were equal to, which shows that side, side, side. So one triangle is congruent to the other triangle. And here is my congruent statement. So at this time, you can do at least 2 additional problems in your booklet, show it to your teacher, and then go ahead and get the next assignment. Thank you for participating. If you have any questions, please ask.